In India, unfortunately, it is a little bit of a wild, wild west. Scooters are catching on fire. Batteries are exploding. That should never be the scenario that we imagine India electrification to be.
As mass electrification gathers pace in India, battery swapping has quickly become one of the hottest terms in the country's automotive industry. When we're talking about battery swapping, who better to speak to than the leader of battery swapping globally? We have with us today the CEO of Gogoro, Mr. Horace Luke. Welcome to News 9 Live, Horace.
Thank you so much for having us here.
So, Horace, let me, right off the bat, start off with the battery swapping policy, which has been drafted in India, and there's been a lot of talk about it, about what needs to go in. There's been a clear focus on interoperability as well. So, just want to understand from you, what are your views on interoperability? Do you see that as an enabler, or do you see some challenges associated over there? What is your view on the battery swapping policy draft that we've got here?
Great. Well, I think first of all, it's great to see the Indian government really paying attention to electrification and how that is possible through battery swapping. When it comes to interoperability, I think it is true that we need an open, more embracing policy to ensure there's going to be the interest of the people when it comes to safety, when it comes to usability, and just overall when they invest in a vehicle, the ability to actually go everywhere, anywhere to swap. Now, however, I think that the technology itself, there's a lot of people building batteries and saying, oh, I can swap, I can do all these things. But the fact of the matter is that it takes a lot of investment to really build up batteries that are durable and safe enough for people to swap millions of times. But I think the translation of interoperability, we need to be very careful so that we have safety in mind, we have flexibility in mind, as well as we have innovation and consumer interest in mind.
Right. Do you see, when we talk about interoperability, a lot of people believe it is standardization of batteries, standardization of battery packs, which is the way forward. But do you see that stifling innovation, and does that also pose a threat in terms of safety risks?
I think Taiwan has taken a really good approach to the problem. They standardize not the form factor, not the connector, not the volumetric weight of the battery, but what they standardized was a level of safety that ensures the public is going to be able to have an apartment building on top and in the parking lot have a swapping station, right? That's an essential part of electrification. How do you make batteries safe? How do you make stations safe and raise the water level for everybody that when they participate in battery swapping and they're offering to consumer is not just a price performance issue, but it really is a safety, durability, and just overall usability issue. But interoperability is not saying, hey, this is it, this form factor, this connector, because that would stifle innovation.
What kind of discussions have you had with the authorities in India with regards to battery swapping? Could you give us an insight into what your inputs have been in terms of where the policy needs to head and what an ideal battery swapping policy needs to look like?
I believe a lot in de facto standard. I don't necessarily believe in the policy saying this form factor, this connector, and use this only, because you don't know where technology is going to go. Technology tomorrow is very, very different than technology 10 years ago. Whoever invests in the right technology, whoever is continuing to innovate, should be the one that is winning the heart of the Indian people. To think about where battery standards should be, I think number one, safety. You need to get the safety of the battery up to a certain level that is world-class, because the density of population here is one of the highest in the world. So therefore, we have our responsibility to make the battery the safest, number one. Number two, traceability and manageability. The ability for you to actually, the government to say, if an incident happened, give me the data of that battery, who has touched it, where has it gone, and then throughout the history of that battery, what has it suffered, and what was the usability of it? Did it ever accelerate in temperature beyond its normal use case? What are the history of that battery? And then last but not least, response. How do you have a battery swapping system that shall a battery station or a battery get either the building's on fire, or in the worst case, something happened to that battery and the station's on fire? Can the firemen ask the swapping company and eject all the batteries so that they can remove all the energy cells from the station on a remote kind of way. Can that be done? You know, batteries are not made all equal. A lot of people say, oh, you know, I use the Tesla battery, right? Oh, I use 21700, or I use 18650. Well, that's just a form factor. Most people don't understand that 18650 only means 18 millimeter by 650 millimeter tall. It's like saying that glass, right? This is the best cup of coffee ever, right? But it's not, because what you put in that glass is very important. Just because it's a Tesla-like form factor does not mean that it is a Tesla, an automotive-grade battery. What we do is that we work with LG, we work with Samsung, we work with Panasonic in a very, very deep level to understand battery chemistry in this temperature, in this usability, and in the swappability of the battery. What's the best chemistry? How do you make a chemistry that is designed for automotive use? Then from the battery, we then design how does a pack handle the batteries? Not only in BMS and functionality, but how do you design for failure? You know, it is inevitable 1 in a billion battery will catch on fire. It is, you know, when you're dealing with chemistry, that just happens. But when that catch on fire, what is your safety countermeasure? What are those precautionary design that you put in that shall that happen, there is no fire. It doesn't become a bomb. It is so great to see the Indian government put such great policies in place to eliminate and to reduce carbon emission. Because with leadership like that, the country will electrify. But we have to electrify in a controlled manner. It is not the Wild Wild West. And I think what we're seeing today in India, unfortunately, is that it is a little bit of a Wild Wild West. If you can get hold of a battery cell, you can build a battery pack. And if you can build a battery pack, all you have to do is certify the first time that golden sample, and nobody's really watching you over the time of manufacturing. So what happens is that the scooters are catching on fire. Batteries are exploding while your kids and your wife and yourself is sleeping next to it while it's charging at home. That should never be the scenario that we imagine India electrification to be.
Right. So what do you think needs to change there? Because I was just about to come to this topic about the fire incidents that have happened, and I have left a dent in the image of the EV industry in India. So what do you think are the measures that need to be put in place now? Because we do have tests, we have stringent tests, we have the AIS 156, which is a pretty tough test for batteries. So what do you think needs to be put in place to ensure that these incidents do not happen again? Because it looks like it's not, these are not isolated incidents. We've seen multiple such incidents over the last few months.
Yeah, I can honestly say that 156 as a testing, both draft 1 and draft 2, it's a good start. But it is a very small subset of what Gogoro provides, or tests that I require my team to do, to make sure to ensure my battery is the safest they can be. So I just mentioned about 10 tons of crush. Can a battery sustain 10 tons of crush? Is that in the test? The answer is no. Can a battery sustain one battery cell within, our battery has 96 cells within. When one of the cells explode, can it contain that energy so that the entire pack is not exploding? The answer is no. Today, we're in Germany, we're in Korea, we're in Japan, we're in Indonesia, as well as we're in China. And very soon, we'll be in India. We're the only system that is in all these countries passing all the regulations that are in the country. So I take all of those standards, put them together, and then add my crazy standards that says I can sleep at night knowing my batteries are safe. And I force our engineers to design to those standards. And so there's going to be a lot more that we're going to be working with the government on to increase the amount of safety standards that I think is mandatory for people getting into this business. So today there are over 200, electric two-wheeler OEMs, right, out in the market. Great majority of them just buying parts on the catalog, bolting it together, not testing, and then shipping to a consumer. That's got to go away. We cannot have that, because that damages the safety and the awareness of electrification of the general public. What we need to do is add to that safety standard, make it a level so that everybody's playing on that level. And that level might be high, it might be painful, but let's not take the easy way out. I'm really going to pay a lot of attention and a lot of energy to really partner with the Indian government to roll out a set of standards in safety that is absolutely going to be something that we're all proud of, instead of trying to be, something that we're going to have to rescue, right? Having batteries, they're now at a station in a corner of a parking lot is much safer than if you're in a building, not knowing what floor, what charger, who's charging a battery, and then you're sleeping one eye open, making sure that the fire alarm doesn't go off. That's not electrification. Battery swapping is not just, solving for electrification, but for convenience sake, but also for safety's sake. Sharing our safety standard and the testing that we go through is the first thing we should do. Being aware that not all energy cell is made equal. Today, a lot of people are building energy cells, building battery packs with energy cells that are just randomly from different distributors or different makers because the cost of those cells are really low. Well, there's a reason why the cost of cells are low, because it's not safe, it's not stable. What we do is that we procure only, and we work with our partners to not only fine-tune the chemistry, but specifically test every cell that comes in before it goes to the pack. That has a level of at least a comfort for me, knowing that the ingredient that's being used for the battery pack is the best one I can do, right? Then we're going to share that subset of testing. And of course, there's going to be things that the industry will find too difficult to do. And there are things that are going to be mandatory, I believe. I think it's beyond the current standard. We've got to increase that.
So Horace, also there's been a lot of talk about battery chemistry playing a role in these recent fires. There's been talk about NMC cells not being safe and LFPs being more suitable for India. So what's your view on that? Do you see a particular chemistry being central to making EVs safer for India, or do you believe there are other factors that are crucial to ensuring safety?
It is actually a very much a misunderstanding or a misnotion that chemistry is the end game, just making batteries that they're not going to catch on fire. Anytime you have energy that's being stored, it is by innate nature, it is under tension and it is unstable. Doesn't matter if it's lithium phosphate or NMC. Batteries don't catch on fire until 160 degrees. When it's 160 degrees C, it'll explode. It'll catch on fire. Any chemistry, okay? Now, battery electronics and battery in general functions all the way up to 85 degrees C. Today in Delhi, I think it were like in the low 40s, but somewhere in India it gets to 50, half the boiling point. But it's not 65, not 75, right? Where chemistry then becomes a little more unstable. We're still operating within the safe range of temperature. It is upon the pack design. Are we doing a right design in the pack so that when that energy releases in an unpredictable way, are we controlling it? Can we stop that energy cell from propagating from one to the next one, or one to the 6 surrounding ones, or in the case of LFP, they're pouches or prismatic. Pouches and prismatic is like when you go to a library and you have a whole bunch of books, right? They're all stacked up against each other. They swell, right? First of all, they swell. They continue. When they swell, they put pressure on the other cell. And then at the same time, when they swell, you talk about this entire surface being heated against the next surface. So when it goes, it goes. Right. Lithium phosphate is no more stable than NMC. Now, if lithium phosphate can actually satisfy the consumer need to shift from ICE vehicle to electric, then absolutely. But unfortunately, lithium phosphate is at its theoretical maximum density. You're not going to see more energy density in lithium phosphate. And lithium phosphate today is about 30 to 40% less energy density than that of NMC. So instead of riding, let's say 100 kilometer with our battery swap, you're now riding 60 kilometer. Are you willing to change over? Because on a gas vehicle, you're doing about 140. If I go over 100, you'll be like, okay, I can do it for now. And then I promise you in the future, we're going to increase in energy density. Say, well, in the future, I'm going to get better. But I can still tolerate 100 kilometer. But if I say 60 kilometer versus your 140, electrification is only going to upset the consumer. Because the consumer is looking at the gas range going, I have the efficiency and the energy I need to do my job every day, or go to places I need to go every day. Now with lithium phosphate, I don't. So it's really starting with the customer satisfaction and customer need first. And then after that, say, okay, what is the right chemistry to do so? And there are alternatives. There are some. We're the first one in the world to have built a prototype, solid state battery that is targeted at 2.4, kilowatt hour. That would be the holy grail of battery swapping. And we're the first to build that solid state prototype, right? Now that's great. When is commercialization? It will take a while, right? But in between then and now, there's electrification and reduction of emission cannot wait. So we got to find something, an alternative solution. And we landed on MMC. When we first started, we started shipping with NCA. Really high energy density, super unstable. But even that, we're able to manage it. So we feel really confident with NMC that we can manage that, basically that pack safety design. Yeah? It is not just in chemistry that we can just solve it. Chemistry will change over time. Battery safety needs to be we need to set the bar high so that no matter what chemistry you put in it, it is safe. And that's what we should do. Not singularly focusing on chemistry, but chemistry is important, but also at the same time, battery pack safety design is also important.
You've manufactured over 1 million batteries. You've done millions of battery swaps. I understand you've also had isolated fire incidents in some cases. So what have your learnings been from those? And how have you incorporated those to make your battery packs safer?
Batteries are innate chemistry. There is never going to be a day where I will tell you that is 100% that we'll never see an incident. We have seen one incident in Taiwan early in our deployment. But what's the beautiful part about our system is that everything is connected. Because of that one incident, we learn so much. And then we're able to program our server to have the proper watchdogs, to have the proper technology and calibration on every one of the battery pack, that then now we can predict which battery might be not as healthy as it should be. And through that learning and through those algorithms, we're able to then manage the battery and catch those batteries before that battery gets unhealthy. Before you get the flu, you have a little stuffy nose, I already got you.
A lot of people say that, okay, Gogoro has done pretty well in Taiwan, but Taiwan is not India. India is a very different place. And there are, those who wonder if Gogoro will be able to implement the model as successfully over here as well. So are there any differences, major differences that you have noticed between Taiwan and India, just in terms of usage patterns or in terms of, just how we ride our roads? What have your observations been on that?
So, in India, of course, there's about 250 million vehicles on the road today, right? For a population of about close to 1.4 billion. So that's about 1 in 6 people, 1 in 5 people, right, have a vehicle. That's the density. What's amazing is that the adoption in Taiwan is much higher than that. Most people don't know that. For a population of 22 million people, there's 14 million scooters. So if you don't count the old people, you don't count the young people that cannot ride yet, we're talking 1 scooter per person. The entire street is full of scooters. So we chose a place where the density of vehicle and the usability of vehicle was extreme, even more extreme than India, I would say. Number 2, it does get hot in Taiwan. Not as hot as India, but it gets to about 38 degrees in the summer. And then plus on top of that, people ride really fast. Our vehicles can go up to 100 kilometers an hour, and people do food delivery, load it up and ride to 80, 90 kilometers an hour. Batteries get hot. So we are in Taiwan, we're able to take all of that and stress test our system, only to the point now we feel so comfortable coming into a climate like India. The usability of India, of course, like you said, is slightly different, but I think it is no less or no more demanding than the market that we're in today.
There are some questions that have been raised about the safety of a hot swap pin as well. When we talk about connectors, some believe a wired connector is safer because a hot swap pin presents the potential of an arcing incident. So what do you have to say about that?
Our battery is designed to be IPX7. That means you can throw it into a swimming pool and the battery still works. Now, when I say it works, doesn't mean it's discharging. The battery, upon only authentication that has properly connected to either the charger or that is connected to the vehicle, does it actually discharge? There is no arcing. When there's arcing, something is not designed right. Our battery has a positive terminal, a negative terminal, and every communication to the battery is wireless. So you can actually, it can withstand any kind of junk on the road. It doesn't matter if it's dirt, doesn't matter if it's mud, doesn't matter if it's any kind of debris that go into the connector or into near the battery. Our connector is designed to fire at 100 amp outbound and also be able to communicate without data pins.
Isn't the rapid advancement in technology, battery technology, somewhat a little bit of a threat to battery swapping? Because one of the biggest plus points of swapping is that it saves you time. You don't need to wait. You just go and you swap your battery and you're done. But now we're seeing fast charging, extreme fast charging. We have firms that are claiming, our batteries will charge in 10 minutes. So, how do you see this progressing going forward? If battery swapping becomes a little obsolete going forward once fast charging really picks up and times come down sharply?
That's a great question. No fast charging will ever get to 6 seconds. That is how fast we can swap a battery. No fast charging can ever get there. Now, with fast charging, of course, there are batteries being in development, right, that can take that kind of energy that fast, right? We're talking about 5 minutes, 8 minutes. But 5 minutes and 8 minutes in this heat is still too much. Now, that said, that's only the battery side. But if you know much about charger, you can pretty much price charger per kilogram. The faster the charger, the more power the charger, the more expensive the charger. There's no way around it, okay? And the copper needs to be bigger, right? The electronics needs to be more expensive because now you have to have a lot more safety design into the charger, okay? So now take that and put it into the vehicle. Then the vehicle is really designed on that sense for recreational vehicle with extreme brands. If you think about KTM and you think about Ducatis, maybe they can afford that because people that buy those vehicles don't care about cost, okay? And they are out in the countryside and they're plugging in 8 minutes. To them, they needed that rest anyway. Great. Inner city, this is where the beauty of our charging cabinet works. The swapping cabinet is industrial grade. The chargers are upgradable. Instead of you having to buy that charger or buying that battery, you don't have to do that anymore. Gogoro takes care of that because we upgrade the cabinets to now charge those new batteries in the future faster to provide that usability in a shared economy model where you're not owning your own charger, you're not only owning your own electronics for safety, but those electronics are being shared with 1,000 people that are also using that station. No matter how fast, everybody goes to work about the same time. Everybody gets off work about the same time. Can you imagine the amount of 200 million vehicles getting off work and plugging into the wall? The energy demand on the grid is going to be unsolvable. Then you go to, how do you time it? Can you only charge at 1 o'clock in the afternoon to 2 o'clock in the afternoon, while he can only charge 2 o'clock to 3 o'clock, and he can only charge 3 o'clock to 4 o'clock? If you have an even plate number, he has an odd plate number. That would be chaos. The Indian people don't do that.
Yeah.
And so quick charging, not only is it a cost problem, but it's also a manageability and the grid availability problem in the future.
Horace, can you tell us a little bit about your India rollout plans? When are you planning to roll out your batteries over here? And what is the number that you're looking at in terms of the batteries that you want to introduce, the number of stations that you want to set up?
We started, having batteries and stations here now, actually onshore in India. Most people don't know. Yeah, it's being tested. And we're going to take a more pragmatic way in rolling out. Even though I have 1 million batteries back in Taiwan, our manufacturing line is ready and capable of producing as many batteries as we need. But at the same time, India is a very complex and complicated culture and usability and environment. So we're going to roll out probably in Delhi, NCR area in a very pragmatic way first. Really kind of gauging, and I'm a person that although we did a really fast growth in Taiwan, but if you look at the first 2 years, it was really a slow growth. Only upon do we know the technology is relevant and working, do we want to offer it to the masses. You won't see me saying, you'll probably see us lighting something up by the end of this year, early next year, in the Delhi area. We are excited, to work with, Dr. Manjal and the rest of the team to finalize the product. We're getting ready to do, close to the end of the year, a launch.
Where will India figure among all global markets for Gogoro?
I think India is a priority for Gogoro. It is one of the most important market, especially with the current petroleum, price. The cost of ownership on an ICE vehicle or CNG vehicle is too high. And if battery swapping can come in and help, it instantly becomes a gigantic market. Our factories, our technology and the manufacturing is designed to scale. A good example is that our battery factory has 46 robots, no people in it. Just several people just with clipboards to make sure things are okay and making sure the machines are operating fine. But this is what I call lights off manufacturing. So I put an energy cell on one side, it tests all the energy cells, it builds the module, it builds the pack, and out comes a battery pack that is onto an AGV and the AGV drives it off. That's how automatically it is, right? Why did I do that? For two reasons. Number one, because the robot don't get tired. The robot doesn't go drinking the night before. The robot doesn't go fight with the family and then go to work and get upset. So predictability and quality is the only way we can get to predictable safety. Number two is because we designed a system so automated that when it comes to India, I'm expecting extreme growth, fast-paced growth. If we're successful, India is going to drag us through manufacturing and say, not fast enough, 5x, 10x.
You partnered up with Hero MotoCorp and you're going to roll out an electric scooter with your platform. So what can you tell us about that? What is Gogoro's contribution there, and what sort of performance and range can one expect from that product?
I built the world's first Nexus phone for Android, for Google. And again, the idea wasn't to sell Nexus phone into the masses, but to use a singular project and form factor to develop the technology, to let the technology then be shared to other phone makers, okay, and create the Android platform. I've taken a very similar approach. We developed the vehicles into multiple different platforms, extrapolate those platforms and components and technology, and then share it with vehicle maker like Hero MotoCorp. With Hero, it's going to be a similar equation. Hero has a great brand equity, largest vehicle maker in India and in the world. They have footprint in over 40 countries, right? Dr. Manjal wants to electrify through battery swapping, and we're here to help with our technology. So just like Google with a phone, that it does Google search and uses the Qualcomm or MediaTek chipset, we are that chipset. We are that search, right? But in that form factor, what form factor, size of wheel, length of vehicle, height of vehicle, style of vehicle, and the distribution and branding of those vehicles, that really is up to Dr. Manjal because he knows India best.
Want to understand your outlook on partnerships. You've teamed up with Hero MotoCorp right now. Globally, you've got partnerships with Suzuki Taiwan, you've got a partnership with Yamaha. So just want to understand, what is your approach to partnerships in India? Are you looking at reaching out to more manufacturers, including established manufacturers, as well as startups, because we have a lot of startups right now, especially in the electric two-wheeler space. So what's your outlook over there? How do you want to approach this?
Well, I think the number one thing that we look for in a partner is mindset, not about necessary capability. Capability can be co-developed together. My goal is to make sure that the Indian ecosystem is a healthy ecosystem. And when I say healthy ecosystem, does not mean just you go into this market and you harvest. That's not what it's about. It's about going to this market and co-developing ideas and technology so it's best suited for this market, so that now that idea and technology uses battery swapping, which happens to be something that we offer. So think of it as a judo move, right? Not necessarily just go in and just say, oh, commercialize. So we're looking for partners to have the right mindset. Mindset in safety, mindset in business model and patience to grow.
It was a pleasure speaking with you, Horace. Yeah. Thank you so much for joining us today. I hope you enjoyed that conversation. Do remember to subscribe to News9 Live for more news, reviews, and interviews.